As we begin on proteins, you're going to start by relating things you've learned about functional groups to the proteins themselves. And so we're going to go through this sheet, this guide to the 20 common amino acids from compound chemistry. You can, from compoundchem.com, and on the learning management system, you can find these listed elsewhere. Nice graphics in many different places. I'm going to use this one and go through it. So the first step is identifying what the backbone and the side chains are. So the backbone is always going to have an amine. Might be written as NH2 or as NH3+. In the body, it's almost always going to be NH3+. But there's your amine, and then a carbon, and then a carboxylic acid. That's the backbone of every amino acid. So I'm going to quickly mark that on these first few. It doesn't always have to be drawn in the same orientation, but it's always going to have that amine, a carbon, and then a carboxylic acid. Connected to that central carbon, called the alpha carbon sometimes, is where the side chain is going to be. And so all of this that's connected is the side chain. Notice this one doesn't really have a side chain. There's an H there. So glycine is the simplest amino acid with no side chain. You can go through the rest of the sheet and do that. You can identify your backbones. On all of your different amino acids. And I'm not going to do it on every one. If you have your a different sheet, it will still have the backbone. Okay, then once you've got the backbone, you can identify the side chains. We can classify side chains according to their chemical properties or their functional, which are related to functional groups. This is just a methyl group, so it is an alkane or an alkyl group, and on this chart it is described as aliphatic. Well, we could say the side chain has an alkane here. Glycine doesn't really have a side chain. It's kind of an in-between, a little bit like hydrogen is on the periodic table. Hydrogen doesn't quite fit with anything else, while glycine doesn't quite fit with any of the groupings of amino acids by type. But here we've got 4 carbons. So this isoleucine is also aliphatic. Leucine, only carbon and hydrogen, also an alkane. Proline, it's got this ring. It's like it's a cycloalkane, but it's also an alkane. It's nonpolar there. The ring is going to give it some different properties from others. And you can go through your entire sheet of amino acids and identify all of the ones with alkanes on the side chains. We've actually done that across the top row here. With some of these, you'll notice aromatic rings. So you've got arenes in a few. And you can continue on. Those are carboxylates with carboxylic acids. with their negative charges. Here we've got another, well, here we have what looks like a whole bunch of amines with a positive charge. This is classified as a basic amino acid. And we've got another amine that's also a basic amino acid in lysine. Histidine is a little bit different. It's got that aromatic ring, and it also has these nitrogen groups. And so it's also basic. It can pick up a hydrogen at this nitrogen up here. So it can be a hydrogen acceptor, which makes it a base. Down here, do you recognize this functional group? Serine and threonine are alcohols. SH is a thiol. CSC, there's a thioether, methionine. And here is the amine with a carbonyl, an amide. So asparagine and glutamine are amides. That is all 20 of the common amino acids and the functional groups found in their side chains.